that says so that you can know where I am. This is the one I'm talking about. Okay, this says a note will pay $50,000 at maturity 5 years from now. How much should you be willing to pay for the note if the money is worth 6.4% compounded continuously? Please look directly at the notes so that you can read it and do the problem with me. All right, so it says that your interest is being compounded continuously, and that's what told me that I want to use what you often like to say is the PERT formula. A equals PE to the RT. Right? So yes, I understand this. It usually applies to dollar amounts, but I mean, we can still use it. It's still applicable. All right, it says that the note will pay $50,000 5 years from now. So that means that your final amount is $50,000. Right? We don't know what you started off with. E, which is approximately 2.718. To the 0.064. Notice I did change that because it said 6.4%, so I changed it to a decimal. And the amount of time that it takes is 5 years. All right, so I'm going to come back to that. Right now, all I'm doing is just setting up these problems. All right, number 2. Again, I'm assuming that you're looking right at the notes on page 8. Okay, it says an investor bought stock for $20,000. 5 years later, the stock was sold for $30,000. If the interest is compounded continuously, so again, they're coming back to that phrase, tells me that I need to use this formula, A equals PE to the RT. What annual nominal rate of interest did the original $20,000 investment earn? All right, so we know that the investment was originally $20,000. We also know the final amount that the investment was $30,000. And they say in order to get from $20,000 to $30,000, it took 5 years. So we're going to leave the E alone. That's always approximately 2.718. We don't know what R is, and we do know that it took 5 years in order to get from 20,000 to 30,000. All right, I'll come back and solve these in a minute. All right, so let me move on. The third problem on page 8 rather. Page 8 says the city of Poppyville is growing exponentially. How long will it take the population to double if the population is growing at 7%? All right, so they come right out and they say it's growing exponentially. So that's what's telling me that I need to use A equals PE to the RT, right? I'm still using the PERT formula. All right, so they say they don't tell you what you originally start off with. They don't tell you what you end up with. But they do tell you that you're growing at 7%, so that's 0.07. And they tell you, actually they don't tell you how long it takes, right? That's what you're trying to find. All right, so then the question is, how are we going to solve this if we don't know what the original amount and the final amount are? So what we're going to do, we're just going to make up some numbers. I don't know, if the population was 4 and it had to double, I think it'll get to 8. So leave everything else alone, 0.07 t. I think we can solve it from there. So again, if there were 4 people initially and the initial population doubled, you have to get it to 8. So what happened if you initially had 15 people? If you double it, you have to get to 30 people, e to the 0.07 t. Now you should be able to solve that. All right, so what I like to do is to make it as simple as possible. I just start off with 1 and I double and get to 2, e to the 0.07 t. Okay, I'll come back to that one as well. Like I said, I'm going to do some setup for these and then I'll come back. All right, here's problem number 4. And 4 has a bunch of parts. It says, recently Provident Bank offered a 10-year CD that earns 5.51% compounded continuously. So there's that phrase, compounded continuously. You know your money has to be growing very quickly. $10,000 is invested. So hold on, let me write the formula down. A equals PE to the RT. All right, so A says $10,000 invested, so your initial investment is $10,000. And it says, earlier you learned that your interest rate is 5.51, so E to 0.0551. Again, I'm converting that to a decimal. And they're saying what happens after 10 years. So they tell you that time is T. Right? So let me be careful because I don't want to just write down A. That assumes that this is the accumulated amount for any time, but instead I want to acknowledge this is your accumulated amount after 10 years specifically. So please make note of this because if you did the notation wrong, then I'm going to take off the points. Right? This is the accumulated amount after 10 years, right? You plugged in 10 in for T. All right. So I'll solve that. And then I want to get to B right here. And B says, how long will it take for the account to be worth $15,000? So it would have been helpful if I just started off saying what the original formula was. So we had 100,000 as the initial investment, E to the 0.0551 times however much time elapsed, right? So in this earlier one, I said what happens after 10 years, but the accumulated amount after any amount of years is 100,000 times E to 0.0551 times the T. So then they're saying, how long will it take for the account to be worth $15,000? So your $15,000 is your final amount. You start off at, I'm sorry, this should be 10,000. I don't know why I'm saying 100,000. 10,000. E to 0.0551 times T. All right, and that's it. So now we have to go through and solve all of these problems. So since I'm at 4, I'm going to go all the way from